In this question, we're asked to balance a kind of a nasty reaction with the smallest possible whole number coefficients. So here we have hydrogen gas reacting with P4, which is white phosphorus, and will catch on fire in contact with air, to form phosphine, which is a gas which will also catch fire when in contact with air and is highly toxic. So the reactants and the product are kind of nasty, but that being said, the balancing isn't so bad here. So the first thing I'm going to do is rewrite the equation H2 gas plus P4 solid yields pH3 gas. And I'm just going to write it with a little bit more room, so I have room to write in the stoichiometric coefficients. Now, balancing chemical equations is a guess and check methodology. So when I look at the reactants, I notice that I have 4 phosphorus atoms. And I notice that on my product side, I only have 1 phosphorus. When people first start balancing equations, they may want to do things like write P4H3 as the product, but you can't do this because this isn't the product that will form. The product that will form by chemistry, for a variety of reasons, is pH3. So you can't form this. This is a completely different compound. So this is not a valid way of balancing equations. You cannot put subscripted numbers. The only thing you can do to not do magic and make phosphoruses disappear is to make at least 4 pH3s. If I have 4 phosphorus atoms on my reactant side, I must have at least 4 phosphorus atoms on my product side. And eventually I must have exactly the same number on both sides because chemistry is not magic. We can't make things disappear or appear as from nowhere. We can only simply balance the chemical equation. So now we have 4 of these. Now, this is a guess and check methodology. So let's check if we can balance hydrogen. Well, if we have 4 pH3s, we have a total of 12 hydrogens. 4 times 3, which gives us 12 hydrogens. If we have 12 hydrogens on our product side, we must have 12 hydrogens on our reactant side. To get 12 H atoms, I need 6 H2s. Now I have 12 hydrogens on both sides and 4 phosphoruses on both sides, so this is balanced. But this is a guess and check methodology. In this case, it worked the first time. It doesn't always. If 4 phosphoruses were wrong, try a different number and try again.